name is Swarna Latha, working as Assistant Professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on sum of two independent random variables. We have discussed about the probability density function of sum of two independent random variables. For example, if x and y, these two are two statistically independent random variables. Now, we have added these two random variables so that we got a new random variable z. Then, the density function of the sum of these two statistically independent random variables is equals to the convolution of the density function of those two random variables. There is nothing but fx of x convolution fy of x. The convolution of the density function of those two random variables gives what? The density function of sum of those two random variables. Therefore, fz of z equals to fx of x convolution fy of x. Or else you can write down fy of y convolution fx of y. So, the convolution of these two density functions gives what? The density function of sum of those two random variables. Now, what is the given problem? What they have given that? They have given that x and y are independent random variables. And the density function of those two random variables is given by fx of x is equals to e power minus x into u of x. And what is fy of y is equals to e power minus 2y u of y. Find the first problem is density function of z is equals to x plus y. And the second problem is what? P. Here P represents a probability. The probability of the sum of those two random variables is less than or equals to 1. So, given x and y are statistically independent random variables. After that, what they are given that? They have added these two random variables to get a new random variable z. So, what they are given, we have to calculate what is the first problem. We have to calculate what? The density function of sum of those two random variables. What is the density function of sum of those two random variables? Nothing but what? The convolution of the density functions of the given two random variables. Therefore, fx of x convolution fy of x. So, this is the formula to calculate the density function of sum of two independent random variables. Now, what they have given that? They have given that the density function of the random variable x is equals to what? E power minus x into u of x. And what is the density function of the random variable y? Fy of y is equals to e power minus 2y into u of y. So, what is u of x? There is nothing but what? The unit step function. How the unit step function has been defined? Nothing but what? This is 1 when x is greater than or equal to 0 and 0 when x less than 0. Now, if you want to write down the density function of the sum of those two random variables, then write the formula as the convolution of the density function of those two random variables. So, they are given fy of y. Then what is fy of x is nothing but what? Fy of x is nothing but what? E power minus 2x into u of x. Now, what is a convolution formula? Nothing but they have given the density function is what type of random variables. If you observe that, they are the continuous random variables. So, here u of x and u of y are continuous. Therefore, the x and y are continuous time signals. For continuous time signals, what is the convolution formula? Is equals to what? Integration minus infinity fx of x into fy of z minus x into dx. So, what is the formula for convolution? Fx of x convolution fy of x is nothing but what? Integration minus infinity fx of x into fy of z minus x into dx. That equals to integration minus infinity. What is fx of x they are given? They have given that fx of x equals to what? E power minus x into u of x. Therefore, this is nothing but what? E power minus x into u of x. Then, what is fy of z minus x? In the given problem, they have given Fy of y is equals to e power minus 2y into u of y. Now what do you want? You want Fy of z minus x. So replace this y by what? Z minus x. Then what can you obtain here? E power minus 2 into z minus x into u of z minus x dx. Just in place of y, replace it by z minus x, because you will write down Fy of z minus x. Just replace this y by what? Z minus x. Then what can you obtain here? E power minus 2 into z minus x into u of z minus x. Now, what is u of z minus x value? That equals to what? This is 1. For what values of x? When x is less than or equals to z. So, if x is greater than or equals to z, then you are getting the negative values. But the unit step function is always 1 only for positive values. So, when you get the positive values here? When x value is what? Less than or equals to z. Therefore, this is 1 when x is less than or equals to z, and 0 when x is greater than z. So, this is a u of z minus x. And what is u of x? The unit step function. This is 1 when x is less than or equals to 0, and 0 when x less than 0. Now, we will multiply this u of x into u of z minus x. So, when you multiply this u of x into u of z minus x, so what are the values of x? This is for x is greater than or equals to 0, and this is for x is less than or equals to z. Therefore, what is the range of x here? You have to write down from 0 to z. You have to write down the common range. So, this is for x greater than or equals to 0 to infinity is 1. This is only for 0 to z, it is 1. So, therefore, the common value is nothing but, the common range is nothing but 0 to z. Therefore, when x is 0 to z, e power minus x into, what is u of x in this? This is 1. So, u of x into 1 into e power minus 2 into z minus x. And what is u of z minus x? When x is 0 to z, it equals to what? 1. Therefore, this is 1 into dx. So, that equals to integration 0 to z e power minus x into, this is nothing but what? E power minus 2z into e power minus 2 into minus x, nothing but e power 2x into dx. So, that equals to integration 0 to z e power x into e power minus 2z dx. So, your integration with respect to x, therefore, whatever the z term that is constant, you can bring it outside. Then you can write down fz of z is equals to e power minus 2z into integration 0 to z e power x into dx. So, I bring e power minus 2z outside because the integration with respect to x. Therefore, it is a constant, so bring it outside. Then you can write down this as what? E power minus 2z into integration 0 to z e power x into dx. That equals to e power minus 2z. And what is the integration of e power x with respect to x? Nothing but e power x only. And the limits are from 0 to z. That equals to e power minus 2z into e power z minus e power 0. That equals to what? E power minus 2z into e power z minus, what is e power 0 value? 1. So, that equals to what? E power minus 2z into e power z. Nothing but e power minus z minus 1 into e power minus 2z is e power minus 2z. This is where what? This is what? The density function of the sum of those two random variables. Next, what you have to calculate? You have to calculate p of x plus y less than or equals to 1. So, next what you have to calculate? You have to calculate what? P of x plus y less than or equals to 1. What is x plus y? Nothing but the sum of those two random variables. The sum of those two random variables we are represented by the random variable z. Therefore, p of z less than or equals to 1. Therefore, what is the probability p of z less than or equals to 1? That is nothing but what? That equals to integration minus infinity to 1 fz of z. From the properties of the probability density function, you write down z is less than or equals to 1, nothing but from where to where z value from minus infinity to 1. So, fz of z into dz. But for what values of z is defined? Only for when x is, what is value? What is the lower limit of z? The lower limit of z is nothing but 0. Therefore, you have write down from 0 to 1. So, 0 to 1, what is fz of z equals to e power minus z minus e power minus 2z. That equals to integration of e power minus z is e power z minus e power minus j. So minus integration of e power minus 2z is e power minus 2z by minus 2. So minus of minus will get here plus. And the limits are from 0 to 1. So that equals to, now we substitute the upper and lower limits. Then what can you obtain here? Minus e power minus 1 plus e power minus 2 by 2. This is the upper limit minus, what is the lower limit here? Minus e power 0. What is minus e power 0? 1. Plus e power 0 is what? 1. So minus 1 plus 1 by 2. So that equals to what? Minus e power minus 1 plus e power minus 2 by 2. So minus 1 plus 1 by 2 nothing but minus 1 by 2. Minus 1 by 2 of minus nothing but here plus 1 by 2. So like that you can calculate the density function of sum of two random variables as well as the probability of sum of two random variables. And what is the next problem here? Two independent random variables x and y have the probability density functions respectively as fx of x equals to x into e power minus x for what values of x when x is greater than 0, and fi of y equals to 1 for 0 less than equals to y less than equals to 1. So calculate the probability density function of the random variable z equals to x plus y. So what they are given that x and y are independent random variable. So what they are given that? They are given that x and y are statistically independent random variables. So for statistically independent random variables, then what you have done? You have to calculate what? The density function of z equals to x plus y. It means they have added these two random variables. Statistically independent random variables. Then what is the density function of the sum of two independent random variables is given by what? Their convolutions. The density functions of their convolution. Nothing but fx of x convolution fy of x. Or else can write on fy of y convolution fx of y. So you can write down, you can use this one or else can use this because the convolution property is satisfying the commutative property. Therefore, so what is fx of x? They are given that fx of x equals to what? X into e power minus x when x is greater than 0 and 0 otherwise. Now you plot this one, how can you obtain? Let us say this is x and this is nothing but what? Fx of x. So what is fx of x? Nothing but x into e power minus. This is exponential decreasing signal. Therefore, let us say this is nothing but x into e power minus x. For x less than 0, it is 0. When x is greater than 0, it is nothing but x into e power minus x. Now, what is fi of y they have given? So, they have given that fi of y equals to 1 when y is 0 to 1. So, when y is 0 to 1 and 0 otherwise. Now, plot this one. So, what is this y? So, fi of y equals to 1 when y is from 0 to 1 and 0 otherwise. And what is the density function formula here? Fz of z equals to what? Fx of x convolution fy of x, that equals to what? Integration minus infinity fx of x into fy of z minus x into dx. So you have plotted the here fx of x. Now you have to plot what? You have to plot the fy of z minus x. So first you plot fy of x. So what is fy of x in terms of x I am writing? So what is fy of x is equals to 1 when x is from 0 to 1 and 0 otherwise. Therefore, when x is 0 to 1, fy of x is nothing but value 1. For other values of x, it is 0. Just replace this variable y by what? X here. Then you got the fy of x. Now, after that, what do you want? You want the fy of minus x. Now plot fy of minus x. Nothing but you just take the time reversal of the given signal. Then you will get minus 1 to 0. The value nothing but what? 1. Then what you do? You require not fy of minus x. You want the fy of z minus x. Then plot the signal fy of z minus x. We just advance this by what? Z units. So if you advance this by z units, what can you obtain here? The lower limit is nothing but z minus 1. And then here z plus 0 nothing but what? Z. And what is this value equals to? 1. So therefore this is nothing but what? Fy of z minus x, and previously you have plotted the fx of x. Now you have to calculate what? Fz of z. So what you have to calculate now? What is the starting point of fx of x? Nothing but 0. And what is the ending point of fx of x equals to infinity? And what is the starting point of fy of y equals to 0? And what is the ending point of fy of y equals to 1? Therefore, what is the starting point of fz of z? Nothing but convolution, nothing but what? Starting point of this plus starting. So 0 plus 0 equals to what? 0. And similarly, what is the ending point of fz of z equals to what? Ending point of the first sequence plus 1. Nothing but infinity. Therefore, your fz of z is existing from 0 to infinity. Now, first case I am taking when z is less than 0. So, since the starting point started at 0, so always since z is less than 0, for this you will get fz of z equals to 0 only, because the starting point of this equals to 0. So now I am going to the second case when z is 0 to 1. So first I am taking from where to where? When z is from where to where? I am taking from first less than 0, then 0 to 1. So when z is 0 to 1, first you plot the fx of x. What is fx of x equals to what? This is exponentially decreasing signal. And what is the signal? X into e power minus x. This is nothing but what? Fx of x. And what is fz of z minus x? Nothing but this is equals to 1 when x is from z minus 1 to z. So here, what are the limits of fz of z minus fy of z minus x? Z minus 1 to z. And what are the limit of z here? 0 to 1. So what is the lower limit here? For example, z equals to 0. Then we substitute z equals to 0, then 0 minus 1. Nothing but what? Minus 1 to 0. Now what is the upper limit here? Z equals to 1. If z equals to 1, from where to where? 1 minus 1, nothing but what? 0. So 0 to z. Now we take these two limits. So minus 1 to 0. Nothing but it is starting from negative value. So z minus 1, and it is taking up to where? It is taking up to the z. And this is nothing but 0. Now if you observe these two, what is the common area? The common area is existing from 0 to z. The common area is existing from where to where? 0 to z. Therefore, fz of z is equals to integration 0 to z. And what is fx of x here? X into e power minus x. And what is this value? Equals to 1. So x into e power minus x into 1 into dx. So now you have to do the integration of x into e power minus x. The integration of x into e power minus x is x into e power minus x by minus 1 minus integration of 1 into e power minus x by minus 1, and the limits are from where to where? 0 to z. Because integration of uv equals to what? U into integration of v minus integration of u dash into integration of v. Here u equals to x and v equals to e power minus x. Then what can happen here? Minus x e power minus x plus, and minus of minus here plus. And integration of e power minus x is what again? Minus. So this is nothing but here again we'll get minus only. So minus e power minus x. So this is what? Integration of x into e power minus x. So the limits are from where to where? 0 to z. Therefore substitute the upper limit, then what can happen here? Minus z into e power minus z minus e power minus z minus, and what is the lower limit here? 0 into e power z, nothing but 0 only, and minus of minus we get here plus. So minus e power 0. That equals to what? Minus, if you take e power minus z common, then what can happen here? Minus e power minus z. So z plus 1 and minus of nothing but plus. And what is e power z value? 1. So plus 1. This is z of z when what values of z? When z is from 0 to 1. And I'll go for the second case. And what is the second case I'm taking here? When z is from 0 to 1 to infinity. What is the second case I'm going to take? When z is from 1 to infinity. So when z is from 1 to infinity, case 2 is the value of z is from 1 to infinity. And when z is 1 to infinity, again you draw the both the density functions. This is x, and what is fx of x? This is a exponential decrease function, nothing but x into e power minus x. And what is the value of z? And what is fz of z minus x from where to where? Z minus 1 to z. So this is from z minus 1 to z. And when z equals to what? 1. So when z equals to 1, then what can happen here? 0 to 1. When z equals to 1, what can happen here? 1 minus 1, nothing but what? 0. So 0 here, 1. And when z equals to infinity, what can happen here? Infinity minus 1, nothing but what? Infinity to infinity. So therefore, you have to take from 0 to infinity. Therefore, you have to take this subject of z minus z, nothing but here. So this is, what is the starting value here? This is nothing but z minus 1. And what is ending value from where to where? Up to infinity is having, therefore z minus 1 to z. Now, what is fz of z equals to here? If you take fz of z equals to from where to where? Integration. And what is the value of z from where to where? It is from z minus 1 to z. And where is z value? 1 to infinity. So, z minus 1 to, and what is upper limit here? Z. So, z minus 1 to z. And in this, what is the density function? X into e power minus x, and this value equals to what? 1. So, 1 into x into e power minus x, x into e power minus x dx. And if you simplify this, what is integration of x into e power minus x? Minus x e power minus x minus e power minus x, and the limits are from z minus 1 to z. And then substitute the upper and lower limits so that you get the fz of z from 1 to infinity. Like that, you can calculate the density function of sum of two random variables by calculating the convolution of the density function of those two random variables. Next, one more thing I have given that the random variables x and y have the density functions fx of x equals to 1 by a into u of x minus a, and fi of y equals to 1 by b into u of x minus b, where 0 is less than a less than nothing but the values of a and b are positive, and value of a is less than the value of b. So find the density function of w equals to x plus y if x and y are statistically independent. So what you have to calculate? You have to calculate the density function of sum of two independent random variables. Then what is fw of w equals to what? Fx of x convolution fy of x. Or as you can take fy of y convolution fx of y also. Now, what is fx of x value? 1 by a into u of x minus a. So, what is u of x minus a? So, what is u of x here? So, u of x, how it is defined? That equals to what? When 1 when x is greater than equals to 0, and 0 when x less than 0. And what is u of x minus a? U of x minus a equals to what? Well, this is 1 when x is greater than equals to a. Only for positive values, this value should be positive, then only get 1, or else you will get 0. So, indicate these positive values when x value is greater than equals to a, then only get the 0 positive values. Therefore, this is 1 when x is greater than equals to 0, and for negative values, nothing but when x is less than a, it is 0. Now, you have to subtract these two, u of x minus a. Then, what is the common value from 0 to a? Therefore, what is fx of x is nothing but this is x, and here fx of x, and the value is nothing but when x is from 0 to a, and what is the value here? 1 by a. So, what is this value? Is nothing but this is a function for what? 1 by a into u of x minus a. So, subtract these two. When you subtract these two, for what values of x you are getting? 1. When x is from 0 to a, you are getting what? 1. And for other values, we are getting as what? 0. So when x is from 0 to a, it is nothing but 1 into here multiplication of 1 by a. So 1 into 1 by a nothing but what? 1 by a. So this is fx of x. Similarly, what is the formula for density function? Fw of w equals to what? Integration minus into infinity. So fx of x into, and here fy of z minus x dx. This is a convolution formula only, which already you know that. So integration minus into infinity fx of x into fy of z minus x. Now you have plotted fx of x. Now you have to plot what? Fy of z minus x. So what they are given that? They have given that fy of y equals to 1 by b into u of x minus u of, so this is u of y minus u of y minus b. So what they are given that? This is u of y minus u of y minus b. So this is the fy of y. Now what is fy of x is nothing but what? 1 by b. Just replace this variable y by x. Then you can obtain u of x minus u of x minus b. Now plot the signal. This is what? X, and this is nothing but what? Fy of x. And what is for what values from where to where? It is 1 by b when x is from 0 to b. So when x is from 0 to b, this value 1 by b. And what you have to plot now? You have to plot fy of z minus x. So first you plot fy of minus x. So what is fy of minus x? This is x, and this is fy of minus x. So this is from minus b to 0. The value equals to 1 by b. Now you have to plot what? Fy of z minus x. So you have to advance the signal by how many units? Z number of units. Therefore, so here z minus b, and here z minus 0 nothing but what? Z. Therefore, this value equals to 1 by b. So what is fy of z minus x? This is equals to what? 1 by b. For what values of x? When x is from z minus b to z value. Now, we will see the density function. So what is the starting point of the density function of the random variable x? See here, what is the starting point here? 0. And what is the ending point here? A. So the starting point of density function is 0, and the ending point of index here actually, index of fx of x equals to what? A. Similarly, what is the starting point of the starting index of fy of x? Here if you observe here, this is 0. And what is the ending index here? B. Therefore, this is 0. And what is the ending index of fy of x equals to what? B. Therefore, what is the starting point of the output signal, convoluted signal? Fw of w equals to what? 0 plus 0 is nothing but what? 0. Similarly, what is the ending point of the convolution of those two signals? Fw of w equals to what? A plus b. Therefore, your Fw of existing from a to where? 0 to a plus b. So when w is less than 0, it is 0. When w is greater than a plus b, it is 0. Therefore, if Fw of w is existing from 0 to a plus b only. When w less than 0. So I'm going for the first case. What is the first case? When w less than 0. Since existing the lower limit is 0 only. So when w less than 0, what is Fw of w equals to 0. And second case, when w is greater than a plus b. Since it is existing only up to a plus b, when w is greater than a plus b also it is equals to 0. Now we have to consider the case between 0 to a plus b. So we'll go for the third case. Case 3 nothing but when w is from a to where? When w equals to 0 to a. So when w equals to 0 to a, we have to consider. Now take what is here? This is nothing but what? X. And what is fx of x equals to 0 to a when x is from 0 to a? That equals to what? 1 by a. Now we have to plot what? Fy of w minus x. You have to plot what? Fy of w minus x. And what is Fy of w minus x range? Nothing but it is existing from where to where? W minus b to w. So what is W here? The range equals to 0. So when W equals to 0, it is existing from where to where? It is existing from where to where? 0 minus B, nothing but what here? Minus B to 0. When W equals to A, so when W equals to A, then what can it is existing from where to where? A minus B to A. It means it may be any value. What is the lower limit here? Minus B, nothing but you have to take the negative value. Therefore, you have to consider the fy of W minus X. The lower limit is at the negative side. And what is upper limit here? This is A. A is nothing but up to A it is taking. Therefore, it may be any value here. Therefore, what is upper limit here? W. So, here W. Therefore, what is the common range here? And what is this value equals to 1 by B. And what is the common area when W exists from nothing but 0 to W. Therefore, F W of W equals to what is the common area of X when X is from 0 to W. When X is from 0 to W, what is this value? 1 by A. It is nothing but 1 by B. Therefore, 1 by A into 1 by B into dx. And equals to what? 1 by AB into, so integration of X and the value of X is from 0 to W. Therefore, nothing but what? W by AB. Therefore, what is FW of W equals to W by AB when W is from 0 to A. Now we'll go for the fourth case. What is the fourth case? When W nothing but when W equals to A to B. Now we draw the fx of X. What is fx of X? It is equals to 1 by A when X is from 0 to A. And what is fy of W minus X? It is ranging from W minus B to W. Therefore, and what is W here? Starting value A. So then what can happen here? A minus B to A. And what is ending value here? B. So B minus B, nothing but 0 to B. Therefore, what you have to consider here? What is the lower limit? A minus B. But what is the A value? A value is less than B. Therefore, A minus A will be less than 0. Therefore, your lower limit will be less than 0. So, somewhere it is starting. So, W minus B. The lower limit nothing but W minus B will be less than 0, nothing but negative value. And what is upper limit here? B. And where is B? B will be greater than A. Therefore, what is W? It can be up to, it is the value may be from A to B. Any value from A to B. Therefore, since it is the B value is greater than A, it is up to here. Therefore, what is the common area here? W equals to here X equals to 0 to A. Therefore, FW of W equals to integration 0 to A. This is 1 by E and this is 1 by B. Therefore, 1 by A into B nothing but what? 1 by AB into dx. And equals to what? 1 by AB into integration of 1 with respect to X is nothing but X and the limits are from 0 to A. Then equals to what? A by AB. Then equals to what? 1 by B. Therefore, what is FW of W equals to 1 by B when W equals to A to B. And what is the next case here? When W is nothing but B to A plus B. So, when B to A plus B, then you have to plot first fx of X. What is fx of X? The value equals to what? 0 to A when X is from 0 to A, the value equals to what? 1 by A. And what is Fy of W minus X? It is ranging from W minus B to W. Now, when W equals to B, then B minus B nothing but what? 0 to B. And when W equals to A plus B, so when W equals to A plus B, so what is starting value? A plus B minus B nothing but what? Here A to A plus B. Therefore, what is starting value here? 0. So, your lower limit nothing but here 0. So, the lower limit W minus B, where it is starting from? Here W minus B. And what is the ending value here? A plus B. So, A plus B, this is A, this is B, and A plus B nothing but definitely it is greater than this one. So, it is up to here. So, W minus B to W. Therefore, if you take the limit here, what is the limit of X? It is from W minus B to A. And what is this value here? 1 by A into 1 by B. This is nothing but 1 by B. So, 1 by A into 1 by B nothing but 1 by AB into dx. And equals to what? 1 by AB. And integration of 1 is nothing but x. The limits are from a to where? A to w minus b. And substitute the upper and lower limits. Then what can you obtain here? This is a minus w minus b. So that equals to what? Here a plus b minus w by ab. Therefore, what is fw of w equals to? It is 0 when w is less than 0. And it is w by ab when w is from 0 to a. And that equals to 1 by b when w is a to b. And this is equals to a plus b minus b by w by ab when w is from b to a plus b. And it is 0 when w is greater than a plus b. Therefore, like that you can calculate the density function of sum of two independent random variables by finding the convolution of two density function of the corresponding random variables. Therefore, in this class, we have discussed about the problems on the density function of sum of two random variables as well as the property of sum of two random variables. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.